Here I am discussing about this SBZ reaction. And what is SBZ the reaction? This is L Bollard-Zelensky reaction, and this is halogenation of carboxylic acid. And what is this L Bollard-Zelensky reaction? When we react this carboxylic acid with chlorine and bromine, and this F2, fluorine and I2, iodine, are not used in this SBZ reaction, only bromine and chlorine are used. And when we react this carboxylic acid with red phosphorus, carboxylic acid with bromine in presence of red phosphorus, here halogen attack at alpha position or with alpha hydrogen, and here this COOH, this is functional group of carboxylic acid, and next to functional group this is alpha carbon, and these two hydrogen are alpha hydrogen. And always bromine in presence of red phosphorus react at that alpha position, and this is substitution reaction. Here halogen atom substitute hydrogen from this alpha position, and this Br2 contain 2 bromine atom, and this bromine atom combine, one bromine atom combine with hydrogen to give HBr, and one this bromine atom combine with carbon to give alpha halocarboxylic acid, and this is alpha, beta, and this is carboxylic acid having 1 2 3 carbon. This is propionic acid, common name, and here at alpha position there is bromine, therefore this is alpha bromo propionic acid. But this chlorine, chlorine in presence of light, there is no specific reaction. In presence of light, bromine does not attack at beta position, but this chlorine also attack at beta position, and here chlorine in presence of light react at alpha as well as beta position. And when this chlorine substitute this hydrogen, this is alpha hydrogen, give alpha halocarboxylic acid, but this chlorine sometime attack at beta position as well. And when one hydrogen is substitute from this CH3 group, here CH2Cl, here CH2COH, give alpha product as well as beta product. Now come to the mechanism, what happen in this chemical reaction. At first this red phosphorus and halogen, this is simple reaction, combine to give phosphorus trihalide or phosphorus tribromide, and always this phosphorus tribromide react with hydroxy functional group, and this is carboxylic acid. This first step, red phosphorus combined with halogen to give phosphorus trihalide, phosphorus plus bromine PCBr3, phosphorus plus chlorine PCl3. And in next step, what happen, this phosphorus trihalide react with this COOH carboxylic here with the hydroxy functional group, not at alpha position at first. And here in PBr3, this PBr3 what happen in this hydroxy group and one halogen atom here mutual exchange, then Br2 Br, this is PBr3, and this OH, there is mutual exchange, this one Br goes to position where there is hydroxy group, means this hydroxy group is substituted by here halogen and give acid halide. This is acid halide, and acid halide are compound obtained by replacing one hydroxy group of carboxylic functional group by halogen. Here acid halide are obtained. And next what happen, another bromine atom, when another bromine atom combine with hydrogen, then give HBr product, HBr, and which one remaining part, phosphorus, bromine and oxygen when combined, POBr byproduct. And in next step what happen, here tautomerization means this one carbon hydrogen bond, this bond shift towards this in between carbon. When this sigma bonds shift in between carbon and here formation of multiple bond, at the same time this pi bond shift towards oxygen, and when this pi bond shift towards oxygen, there is negative here positive, and this pi bond shift here and form here multiple bond in between carbon, and this negative charge carbon attract with this hydrogen to give OH group. Means here simply what happen, this pi bond shift towards oxygen and this carbon hydrogen bond shift in between carbon, and this hydrogen migrate to this oxygen and give this compound. And in next step what happen, in next step another Br2 molecule, this is another Br2 molecule, react with this obtained compound, and here this pair of electron, here oxygen contain lone pair electron, and this lone pair electron of oxygen, or not this lone pair, here this oxygen hydrogen bond shift in between carbon and oxygen. Means here in between carbon and oxygen there is formation of multiple bond and H plus is released. Here give H plus and here Br, and one bromine combined with this H to give byproduct HBr. HBr, and when this pi bond shift here, this carbon attract this Br, and here give alpha halo acid halide. And in next step what happen, in next step this alpha halo acid halide react with another acid molecule, and when this molecule react with another acid, there is exchange of their alpha halogen and alpha hydrogen, and here this halogen shift into this acid at the position of hydrogen, and this hydrogen migrate to this carbon, then here Br give this product. This is the mechanism behind this SBZ reaction. Means here give alpha halo carboxylic acid and another byproduct here acid halide, and this acid halide participate in further chemical reaction.